All right, hi, this is your Unit 5 quiz review video. I printed this at my printer at home, and my printer kind of ate the paper up a little bit, but we are going to persevere. It still printed all the problems, so we'll make it through. All right, this first one looks like it needs to be partial fractions, so I'm going to start by factoring the denominator. It's going to be x plus 1, x minus 7. So I'm going to just do a margin problem sort of off to the side here. I guess I could have just written this here and I wouldn't have needed to write it there, but oh well. And we're going to make this be a over x plus 1 plus b over x minus 7. And it's just going to be a whole big lot of algebra. We're going to go through and multiply all three of these terms by that common denominator. On this side, the whole thing is going to cancel out. Here, just the x plus 1 would cancel, so we'll have a times x minus 7, and then this is going to be b times x plus 1. So if x equals, and I'm going to make the first one be 7, then we're going to have, what would that be, 35, 36, 37. So 37 equals, this part will cancel, that was the whole idea, and it would be b times 8. And so if you divide over, b is 37/8. It just comes out to whatever it comes out to, so don't let that bother you. We're going to let x be -1. This side would be -5 plus 2, which would be -3. And then this would equal a times -8. And so it's going to give us a is 3/8. So when we come back over here, and this is all algebra, none of this is even calculus at all. Come back over here and put it back into our integral. It's a little bit washed out. You're going to put back in this part. So it's going to be a, which is our 3/8, over x plus 1, and then plus b, which came out to 37/8 over x minus 7. Let me see if I can turn that light down a little bit. Is that any better? Come on. No, it's still pretty washed out. Come over here. All right, and then dx. So when you do your antiderivative, it's going to be 3/8 ln x plus 1 plus 37/8 ln x minus 7, and then plus c. So this whole thing is our answer, which is the only step that was any calculus, was doing the antiderivative. You're just doing a big bunch of algebra to get this separated into two different fractions so that you can do this, because a regular old u substitution is not going to work there. All right, looking at this one, I have a product of two functions. I have x and then I have sine. So this is going to be our integration by parts. So we're going to let u equal x. dv is going to be the rest of it. So du is going to just be dx. V, if you do an antiderivative, there would be a u substitution. I guess you couldn't use u. You'd have to use a different letter, I suppose. But you're going to just put a 1/5 in front. Actually, it's going to need to be a -1/5. I'm talking, so I'm not thinking here. -1/5 cosine 5x. Your derivative of cosine would be negative sign. So when we're going backwards, we just need the negative there to cancel it out so that this ends up being positive. Now, if you write it this way every time and just stay organized, it's going to start out being that you multiply across. So I'm going to have -1/5 x cosine 5x. So -1/5 x cosine 5x minus integral, and we're going to multiply these together. So -1/5 cosine 5x and then dx. So these negatives are going to cancel. This first part is done. We're sort of just copying that at this point. And we're going to do another antiderivative. So your antiderivative of cosine is sine. You're going to need another 1/5. So a 5th times a 5th is 1/25 sine 5x and then plus c. So again, mostly a margin problem. Like a lot of your work is happening off to the side there. All right, this is one of our improper integrals. This is a p series. P is 1/3. And so if we notice that, here, actually, hold on, my dog is barking downstairs, so I'm gonna have to go grab it. Hold on one second. All right, and so since p is lower than 1, equal to or lower than 1, we know this is gonna diverge. So we don't even really have to do the problem. That's only going to work for 1 to infinity, but it's that way on your quiz. I set it up that way on purpose so that if you notice that, then you can just go ahead and do that. Now, say p was bigger than 1, then your answer is going to be 1 over 1 minus p. So whatever p is, you just plug it into that formula. All right, this is another partial fractions one. It's just already factored for us. So I'm going to make this equal a over x plus 1 plus b over x minus 4. I'm going to multiply all 3 of these terms by that denominator. I'm going to say if x equals 4, then 3 times 4 is going to be 12. This part cancels. It would be b times 5. So b is 12/5. And then I'm going to let x equal -1. That's going to make this side be -3. And it would be a times -5. This part would cancel out. So a is going to be positive 3/5. We're going to take that. This is the part that you're substituting back in, inside of your integral. It's going to be 3/5 over x plus 1 plus, what was b, 12/5 over x minus 4 dx. And then we're going to do the antiderivative. So 3/5 ln x plus 1 plus 12/5 ln x minus 4 plus c. All right, this again, I have a product here. We have an x and then we have a exponential. So this is going to be our integration by parts. U is going to be x, dv is going to be everything else. It's going to be really similar to the other one with a 1/4 instead of a 1/5 that was in that sine one. Du is dx, v is going to be 1/4 e to the 4x. So again, we're going to multiply across. It'll be 1/4 x e to the 4x. Minus integral, and then we're going to multiply these together. So 1/4 e to the 4x dx. First part just stays the same. Again, we're going to need another 1/4 for this. So it's going to be minus 1/16 e to the 4x plus c. All right, and then this last one, another improper integral. So I'm trying to put this where the light catches it better. We're going to have to actually work this one out because it's not 1 to infinity. So we're going to do limit a goes to -infinity. Now, usually we use a for the lower boundary and b for the upper boundary. It really doesn't matter what letter of the alphabet you pick as long as it's not x. But I'm going to stick with, what a textbook would do. So a for the lower one, b for the upper one. So we're going to have a to -2 x to the -5th dx. So when we do our antiderivative, we're going to add 1 to that power. So it's going to become -4. I'm just going to do a side problem here so I can see it. In front, you would need a -1/4. And yes, you have to write limit every single time. If you don't have your notation, then it's not correct. So you do need to do that. Now, I'm not going to write the integral symbol because we're doing our antiderivative. This would be -1 over 4x to the 4th. So I'm bringing that negative power back down to the denominator, such that a to -2. One more time, writing limit. So they're 4-step problems. The first one, you fix your limit and your boundaries, and then you do the antiderivative. And now we're going to do upper minus lower, and then your last step is you evaluate the limits to get your final answer. So plugging in -2. -2 to the 4th would be positive 16 times 4 would be 64. So -1/64. But you would be within your rights to put this because it's not multiple choice and you're allowed to leave free response alone. So I ended up writing it anyway. I was going to say I don't feel like writing that, so I would put it this way. But if you aren't sure what -2 to the 4th is and then times 4, you can leave it like this. All right, and then plugging in a, you're just basically recopying it but with an a in there. All right, so we're going to imagine plugging in a very, very large negative number. You take it to the 4th, that's an even power. So it's going to become a very, very large positive number. Either way, it wouldn't really matter. The point is this denominator is getting astronomically huge. So if you have 1 over a trillion, it's essentially nothing. This part is going to go to 0. And so you're just left with the -1/64 for your final answer. And that's typically the way that these go when you're approaching infinity or negative infinity. you have something in the denominator that's going to get super big, then this portion is going to go to 0.